Hello and welcome to section 4 of the Automated UI Testing in Java video course. Previously, we've created the basis for UI framework and we've updated our sample tests accordingly. So, our current solution is operational for trivial cases. But this time, we'll take a look at more complicated cases which appear as soon as you start working with more or less complicated environment. In this section, we'll go through several quite common cases for complex pages and elements handling. Firstly, we'll take a look at platform-specific identifiers and how to deal with multiple independent platforms. Secondly, we'll work on customizing elements behavior to make custom elements compatible with standard elements. We'll take a look at how to deal with compound elements containing sub-items, and in the end, we'll go through some additional functionality which helps us with the verifications and which would be helpful in the future. In first video, we'll take a look at platform-specific identifiers. They normally appear when we operate with same application implemented under different platforms. In this video, we'll introduce the enhancement which handles platform information. We'll create functionality supporting multiple object locators for the same element and apply changes to choose the most appropriate locator for the platform. In the end, we'll create an example which verifies objects on page using platform-specific locators. We'll exercise the same test on web and Android platform to demonstrate that we can declare page objects for several independent and incompatible platforms. So, let's get started. Since we introduced the concept of platform, we need some entity which stores relevant information about it. The first step is to create new enumeration called platform. In addition to constants, it should contain private field value which should correspond to the platform or browser name from our configuration file. We should create constructor initializing this field and getValue method which returns the value of our private field. Then we can add constants which have the string value associated. In addition to browsers, we'll add two more entries for Android and iOS native applications. Also, we'll add an entry called any. It will be needed for filtering when we need some identifier matching all supporting platforms. After that, for better convenience, we can add two methods which define whether current platform is Android or iOS. Next two methods verify if requested platform belongs to a specific group of platforms. For instance, native mobile applications require path to application package, while web applications use URL for the start page. We'll exercise that later in this video. And finally, we need to have a method which converts string from configuration file into platform enumeration value. Thus, we add fromString method which returns the constant matching specified input string. Now we are done with enumeration. Next step is to update configuration object to handle the platform. Mainly, we need to add just one method which gets the browser configuration parameter and transforms it into platform enumeration, which is then returned. And finally, we need to update the driver object. It uses hard-coded values for browsers. Having platform enumeration, we can replace hard-coded strings with the values from enumeration. Since we are going to introduce mobile native application support, we also need to include entries from Appium into our Gradle or Maven. For this purpose, we need to include additional dependency for Maven. If we use Gradle, the entry is similar, just with a different syntax. Once we have it, we can update driver object with two additional entries in driver map field. Those entries correspond to Android and iOS drivers respectively. Now it's time to add platform handling into locators and into find-by annotation in particular. Firstly, since we potentially need multiple locators, we need to make our find-by annotation repeatable. For this purpose, we have to add new annotation called find-by list. It contains the only field values and returns the array of find-by elements. Once we have it, we can update find-by annotation with additional attribute. It is a repeatable annotation with find-by-list class as the parameter. This way, we define that multiple find-by annotations can be assigned to the same element, which is not allowed by default. Note that this capability is available since 1.8 Java version. If you use older version, this functionality wouldn't work. One more change to apply for find-by annotation is to add platform field which returns any by default. This way, we still keep compatibility with previous behavior. Now, we have to handle find-by annotations from pages. For this purpose, we need to update PageFactory class. What changes this time? Firstly, instead of getting single annotation, we can use getAnnotationsByType. It will return the list of annotations of find-by type. This makes things easier, and now we can get rid of getAnnotationField method. Now we need to get specific find-by annotation matching the current platform from the list of all find-by. For this purpose, we'll add new static method. Let's name it getLocator for platform. It goes through array of find-by elements and returns the item, which platform matches the parameter we pass. If nothing matches, the null value is returned. Now we can get back to init method. We have a list of find-by elements and we have method filtering this array by the platform. Let's initialize new annotation object with the find-by element which contains current platform. If this object is null, we'll try again by searching for platform with the value of any. It means that if we don't find a specific locator, we'll look for common locator then. Once it's done, we just initialize control object with the locator string. Now we can actually remove getAnnotationField method as it's no longer used. So, after all those changes, our PageFactory now handles multiple find-by annotation, and it can choose platform-specific one. Now it's time to update our sample test pages with platform-specific locators. Right now, we'll take the search page. I chose Booking.com application for the purpose. It's available both as website and native mobile application. Initial UI is almost similar, but what is definitely different is identifiers. Let's open Appium and see how corresponding URL objects are defined. For the Appium setup information, please refer to Getting Started page of the official Appium site, which URL is on the screen. Here, I'm using Appium Inspector running Booking.com Android application on the Genymotion simulator. If we take a look at each identifier we are interested in, we can see that each of those elements contains a resource ID, which is used as ID for Appium. This is pretty much good, as ID is one of the most convenient locators. Now, for search page class, we'll add additional find-by annotation for each field we need, and we'll set corresponding identifier from the mobile application. After all the changes, we have updated the search page, which is now supposed to be compatible with both web and Android versions. Now it's time to prepare sample test. At the moment, we just need to prove that we handle UI definitions depending on the platform. So we don't need to dig too much into behavior of applications. Handling different behavior of similar elements on different platforms will be covered in the next chapter. For this video, we'll create new test which just verifies the UI elements on Booking.com landing page. Before adding new test, let's move some common functionality out of our existing sample test. We'll create test common class and copy before and after methods from our sample test, as well as we'll move our page declarations. Now we can get back to Booking search test and extend this class from test common. Test should work the same way. Next step is to create search page UI test class extended from test common, where the only test verifies element's existence. We initially assume that we are on landing page and search page instance is initialized as it's done in common class. We can run it to confirm it works for web application. Now let's make changes to make it running for Android. Firstly, let's open config properties file and add 3 more entries. They are: first, the driver URL, the URL of Appium server. This one is the default, but if you use different one, you can specify your own URL. Second, application path. I'm using application package which can be downloaded from the device. It's APK file. Generally, it's needed if application isn't installed on the device. Third, platform version. The version of Android platform to run tests on. Then we go to the driver class. Unlike browser-targeted WebDriver instances, the Appium instances require URL to connect to. Thus, we need to have another add method which accepts URL and calls a bit different constructor. After that, we can go to test common class and check setup method. Right now, we don't have any specific capabilities yet, but for Android driver we need some. Let's add them. Here, in particular, we define platform version and application path from configuration file. Ideally, the platform name is also to be retrieved from the configuration file, but for now it's not that essential. Next step is to update driver initialization. For web, current initialization is okay, but for Android it's not enough. Here we can use isWeb method of the platform enumeration to differentiate web and native platforms behavior. For native platforms, we also add URL as the parameter. One last small tweak. We use navigate method to open the page, but for Android application it appears at the application start. So we have to update this method to open the page only for web applications. Now we can run our sample test for Android. It passes. Now let's switch back to Chrome configuration and we'll see that the same test for web application also works. This is it for this video. We've introduced multiple locators for page elements. Also, those locators are handling different platforms, selecting the one which corresponds to currently configured platform. And finally, we've created sample test which is runnable both for web and Android. Since those two applications use different UI type with different identifiers, the successful test run results prove that platform-specific locators enhancement works. In this video, we've just looked at the way to define similar elements and different locators for different platforms. But our elements may also behave differently on different platforms. It makes behavioral difference